this video, I'm going to go over how you can use timers and counters in your code block. Once again, on the right hand side, if you go to the instructions tab, under basic instructions, you open the timer operations folder. We are going to be using the TON. This is the on delay timer. Drag it out onto your branch, and it's going to ask you to name a data block for this timer. This is basically where it stores its internal information. You can just leave it on default and click OK. Now, when you're using a timer, you have to look at three things. The first is your in branch. When the timer gets power on the in branch, that's when it activates. Now, in the case of an on delay timer, there's a certain delay between the activation on the in and power going out on the Q. That time is defined in the PT, which stands for preset time. In our case, let's do 2 seconds, so just 2S, and it will define a 2-second delay between input and output. So let's put a switch on the input and our LED on the output. So use switch 3 and LED 2. We're going to download this to our device. Then we'll bring up the simulation again. Make sure you're monitoring so you can see what's going on. You'll notice this little gray box on top. This is telling you what the time is for this timer right now. At the moment it's 0 milliseconds. When we activate switch 3, it's going to wait 2 seconds. You'll see them up here. And then it's going to activate the output LED over here. So switch 3, I0.2. That's 1 second, 2 second. Then it activates LED 2 and it turns on over here. Now if I turn off the switch at the beginning, it's going to turn off the output straight away. This is useful for when you want a delay between your activation state and your output state. So if you want something to happen for at least a certain amount of time, then this is useful. So you don't want to trip the alarm door, for example. As soon as somebody opens it, only if it's left open for 5 seconds, you would use an on delay timer. Another useful function is flashing something on and off. I'll show you how to do that right here. So we're going to keep this timer and we're going to add another one onto the next network. Again, default for their database or data block. Now in this case, instead of activating the LED, or as well as activating the LED, we are going to activate a memory bit. Memory bits work the same as your input and output bits. They're just stored in the PLC, so you can use whatever address you want. In this case, I use 0.0. So when this is activated, it's going to turn on the LED and also activate the memory bit, which I then want to connect to the second timer. So, and I normally open contact with memory bit 0.0. Over here you'll notice I'm adding a normally closed contact with memory 0.0. These two are exactly the same except for their beginning states. So this one starts closed, this one starts open. What this means is no matter what the state M0.0 is in, only one of these networks can be activated at a time. That's a good way of making sure you don't activate them together and then cause confusion on the LED on or off. Now one thing you want to change for the LED is to make sure once you're offline that you set it to, oh, let me bring it in. want to use a set bit right there. The reason for this is when we activate the memory bit right here, it's going to turn off. The bit is going to be changed to 1, which opens this contact and turns off the timer, but we want the LED to stay on. So what we do is we set it to make sure it stays on even if your initial memory bit turns off or your timer power turns off. So when we have this, it goes here. Wait another 2 seconds. Now we want it to, in this case we're going to reset the LED, so this is the 2 seconds off. And at the same time we want it to activate, 1 second. What I'm going to do right now is, because the timer bit in this case can only have 1 output, like you can see here I'm using 2, to avoid an error in the compilation later on, I'm going to split this up to a second network. So instead of both of these being right after each other on the timer branch, I'm going to drag the LED down to this network, and I'm going to connect it with that same memory bit. So now what's happening is, when the timer activates, it turns on this memory bit, which starts the other timer, but also turns on the LED. Now what do we want the second timer? We want it to turn off the LED, right? So I'm going to use memory bit 0.1. That's going to go to a branch where we turn off the LED. Again, we're using the reset output, LED 2. Memory 0.1. Yeah, so I changed them to set and reset. What this makes sure is, when the second timer is activated, it's going to close this timer and open this one, and so we'll start on the initial 2-second count before turning on the LED. This or download it to device. When I compile this, I notice it's telling me there's an error. If you click on the question mark under the compile menu, it will tell you what the reason is and where the problem is. So in this case, it's telling us 4 and 5. Network 4 and 5 is where it's having a problem. If we look up here, 4 and 5 are where the networks with our timers. So what was the problem? Q output can only be interconnected with a coil. We have that. But the problem is I'm using set. It isn't like set. So let's use this here. Actually, stop it. I kind of lost.